Okay, today we are going to look at how we can deploy an application on your AWS instance. Everything is going to be done manually for now, just to get you familiar with how the application works. And the idea is that after we get more comfortable with how the application works, we can start automating its setup. I'm going to walk you through the different steps that you have to take in order to make that happen. The application is made of three main components. The front-end part, which is basically just HTML and JavaScript, which is in the front-end folder. It just contains one index.html file, and you will see that this HTML file does an AJAX request to /JSON, and then changes the DOM based on the output from this API. So there is the front end here, and there is another bit, which is the backend. The backend is in the backend folder, and it's a Python application using Flask that is basically an API that uses a MySQL database in the backend. So the first thing that we're going to do is setting up the front end. That's pretty easy. We have the front end folder. It's just an index.html file. So we can SSH to our AWS instance, make sure that we have Nginx installed and running, and move that file to the proper location. So I have the IP address of my instance here, so I can SSH to it. Okay, new host key. And I'm back on a fresh instance. Nothing has been done on it yet. So I'm going to install Nginx. That was quick. I can check that Nginx is running. And then I can have a look at my Nginx configuration file, which is in /sites available /default. So it's the same file as usual, lots of commands. The one thing I'm going to do for now is that I'm going to change the root folder of my Nginx configuration file to a different location. I'm going to use /frontend for this demo. You don't have to use, well, you can use pretty much any location you like, as long as it's accessible to Nginx, to the Nginx user. I'm going to save this, and I'm going to restart Nginx. All right. Nginx is running. I restarted it because I made changes to the configuration file. Now the issue is that this /frontend folder does not exist. So I'm going to create it. I need to use sudo because I don't have rights permissions to create a folder in /. So I'm going to use sudo for that. And then this folder has been created. It belongs to root because I created it with sudo. So what I'm going to do, and there are all kinds of different ways to do it, is that I'm going to change the ownership of that folder to Ubuntu so that I can write to it using SCP. So now if I look at my folder, it's owned by Ubuntu, which means that from my computer, I can copy a file with SCP and I will have permissions to write directly onto this location. I'm going to exit the shell on my AWS instance, and I'm now back on my laptop with all my files. And then what I'm going to do is use SCP to copy the index.html file onto my instance. So Ubuntu at the IP address. I should copy paste the IP without spaces. And then I'm going to specify the location here, and I'm going to say that I want to copy that file into /frontend. That is going to work only because /frontend has been adjusted so that Ubuntu can write into it. Okay, so the file has been copied. And now I can check on my browser to see if everything went fine. Okay, so this is the browser view of the AWS instance. This is the IP address of my instance. And you can see a web page that's been loaded, which is the index.html that I created, that it's coming from my app. And it says that there are dynamic elements loaded from the backend. And we should look at the JavaScript console because obviously there's nothing showing up here. So we can look at the console, and if you look at the console, we see that there are lots of errors, and one of the errors is that the Nginx server could not find /JSON. So /JSON is going to be the endpoint for the API. What we are going to do now is set up the backend so that it can actually respond to requests, and then we are going to configure Nginx to forward all HTTP requests received for /JSON to the backend API. So back in the shell now, I'm going to set up the backend to make sure that it works and that the front end can use the API to load stuff on the web page. So the first thing I'm going to do is copy the source code to my instance. Use -r because I want to copy a folder. My bad, I want to copy backend. So I want to copy the backend folder recursive because I want all the files be copied over. And I want to copy that into the home folder of my AWS instance. Okay, all the files have been copied. I can SSH to the instance. And I should see my folder here, backend. So now I'm going to set up this as a service so that it works well on my instance. So the first thing that you are going to do in order to make that happen is that you want to create a service on your instance. So you'll have something. You don't want to run this backend manually. You just want to have it defined as a system service like Nginx, for instance, where every time you boot up the instance, it just works and it's starting the service automatically. This means that your backend application is going to run all the time on your Linux instance, and you want to use a dedicated user for that, mainly for security reasons. So I'm going to create a user, which I'm going to call backend, which is going to be the user running that application and owning all the files for the application. So I'm going to use user add -m to create the home folder, and I'm going to use /backend as the home folder for that user. And I'm going to create the user backend. So this is the path to the home folder. So it starts with a /, and this is the username of the backend user. So now this user, oops, my bad. Now this user has been created and is available in my system. And if I look at /backend, you can see that it all belongs to the backend user. So now, because I'm the Ubuntu user, I cannot write into that /backend directory. So I'm going to use sudo here to copy all the files. I have everything here in backend. This is like our source code. So I'm going to copy all these files, the whole folder. I'm going to move it into /backend/src. So this means that I'm moving the folder, which is backend, in my current folder, which is my home, and I'm going to move it into /backend/src. And I'm using sudo because I am the Ubuntu user, and /backend is owned by the backend user. So I cannot write to it as the Ubuntu user. Okay, I can double check. Now I have this src folder, which is my source code. Problem is that it belongs to Ubuntu and it should belong to backend. So I'm going to change the ownership recursively to Ubuntu of the whole src folder. Sorry, not Ubuntu, backend. So here, because I am the Ubuntu user and I want to give ownership to another user, I need to be root. So I need to use sudo as well. And now my /backend, well, it still has the group, which is a little bit funny, but everything belongs to the backend user, and we are ready to set up the application. So now, since we want everything to be done by the backend user, I'm going to change into that user, and I'm going to start setting things up as that user. So in order to open a new session with the backend user, I'm just going to use sudo, which will allow me to use su, that will let me change into a different user. I'm using minus to create a new environment in my new shell, and I can change into the backend user. So this is my backend user shell. It looks funny because it's just a simple shell and it's not bash. If you want to have a nicer prompt and way to type in your commands, you can just start a bash shell by just typing bash, and then you will see very obviously that this is the backend user. Because everything is going to be automated in the end, this is not really a problem for us at that stage, because we are never going to use an interactive session for the backend user. As it happens, the backend user should be hardened, because here we didn't even set a password. We should lock this account and make sure that we cannot connect to it. But this is part of your security course and not really part of this automated deployment situation. So we'll just make it work this way. I'm going to use bash now to run my backend commands. So I'm now in the home folder of the backend user, which is /backend. And I have my application available in my src folder. So this is a Python application. And as with many applications, it uses external libraries, external modules. And the list of modules that are required is listed in the file requirements.txt. So what we are going to do now is make sure that we install these requirements for the backend user so that we can effectively run our application. So I'm going to use the pip command, which allows me to install dependencies in Python. And because I'm not sure what's installed on my instance, it looks like I do have Python 3 installed, which is 3.8, which is good. I don't have pip or pip3. I would need to install another package in order to install pip, which is what is required to install external dependencies in Python. So I'm going to start with that. Install Python 3-pip. Now, this is not going to work because now you're the backend user. The backend user does not have sudo access, and you don't want to give sudo access to the backend user because ultimately it's going to be a system account that runs your application. So what I suggest is that you run another SSH session in another window with the Ubuntu user running, so that you can run commands with sudo in a different window without losing your current session in with the backend user. This is what I've done here. Created a new shell with the Ubuntu user, and I'm going to install pip using Ubuntu, the Ubuntu user. I'm going to go with yes. Okay, I was not really expecting that. Did I type everything right? Maybe my apt sources are out of date. So I'm going to make sure that they are updated by running apt update. And then I'm going to install Python 3. So I just did apt update to make sure that all my package repositories were up to date, so that I can effectively install pip for Python, allowing me to install external dependencies. So pip is getting installed here. We're almost done. Great. So now I'm guessing that I maybe have pip. Okay. But since we're using Python 3 and we're using system-wide Python, maybe we want to use pip 3. Python 3.8. Yeah, I'm going to use pip 3 just to be on the safe side from now on. The topic of Python environments is always a tricky one. So now I'm going to use pip 3 to install the dependencies for my application using the -r. And what this is going to do is that it's going to install these dependencies for the current user. And because we want to be explicit, we are going to say that we definitely want to install them for the current user only, so that pip doesn't try to do anything funny with our module. Now it's installing the dependencies, and you have this interesting message. It's telling you that your binaries, your dependencies come with binaries, for instance, Flask, that have been installed in the /backend/.local/bin folder, which is not in your path, which means that most likely if you run Flask, you will see a weird error message saying that Flask is not found, even though it's been installed when running the pip command. This is because the binary is in this location. And if you use, which is not in your path, and if you use the full path to that binary, then it actually does work. You do get a Flask binary there. So this is something that you'll have to remember when setting up the application later on. My apologies, I made a mistake. I used a former version of the application I wrote, which was missing a dependency in the requirements.txt. We're going to use MySQL as a data store for our API. So in the requirements, you should have a line that reads MySQL client. I forgot to use it when I just did my pip install command. So what is likely is that you will get an error message like this, saying that you cannot install all the dependencies. So here, the reason is because I'm using a pip module, a Python module called MySQL client, and this module requires additional libraries to install. And the system library that you need is called libmysqlclient-dev, I think. What we're going to do is that I switched back to my terminal with the Ubuntu user that has sudo permissions. And in order to be able to run that Python module, you'll need to have the libmysqlclient-dev package installed on your system. So you can do something like apt install libmysqlclient-dev. That should work. And say yes. Okay. And now if you run the pip install again, everything should go fine. So now what you can do is try to run the Python application like this and see what happens. I wrote the app, so it's probably not that great. It's just a demo app. You can run it straight like directly with Python, running Python 3 wsgi.py, or you can run it through gunicorn, which is a WGI server, which is the recommended method. Just to debug, we can just run it manually like this and see what it tells us. So here it doesn't work, and we have a huge traceback in Python, but the most important thing is that it tells us that it cannot connect to the MySQL server. The reason for that is because our API is using a configuration file called backend.conf, and this configuration file is expecting a MySQL server to run, well, in that case, on the local machine, and with a user already set up and a database already set up. So if we want our application to work, we will need to set up a MySQL server. So I'm going to switch to my Ubuntu terminal so that I can install MySQL on my instance. And if I'm not mistaken, you should be able to do apt install MySQL server. This is a pretty huge package, so that may take a bit of time to install. And now it's installed. And now I can check. What is the name of the service? MySQL? Yes. I can check that MySQL is up and running. It's been installed, it's enabled, and now it's running. Once again, this is a provisioning course, and it's not a database course. So I'm not going to go too much in details on how you should harden your MySQL server so that it's not widely open without password like it is now. This is something that you can do on your own time. I'm just going to use it as is, and well, first of all, check that it does work. So MySQL has all kinds of different ways of authenticating users. When you install it and you don't do anything, which is not the recommended way of doing it, it's fully open for the root user. So you can actually do MySQL -u root as root yourself using sudo, and you'll get access to your MySQL shell. Here I can see that I have a couple of databases available on my system. My backend user, which is on the other terminal, expects a MySQL user called example and a database called backend. So I can definitely create the database backend in MySQL. And now I have this new backend database available. Now I will need to create a MySQL user with a password and give it permissions to access this database. So now I'm going to, I switched back to my SQL screen, and I'm going to create a user. So the user here is example. And what's really important here is that as the backend user, you could change the configuration file. I'm going to do that and change the user to video. What's really important is that all the components match in terms of settings. So if you want to use a different user here, it's fine. You just have to make sure that this user is created on MySQL as well. So now I created this user called video, and I'm going to change its password by doing MySQL is kind of rusty. So I'm going to alter user video at all hosts, just to be safe, identified by, what's the password? secure. So once again here, as long as you use the same password here and there, you should be fine. That worked. And then I want to grant all privileges on backend all tables to my video user from any host. Okay. So now I'm going to flush my privileges. Okay, and now I'm going to exit. And I'm going to connect to MySQL using the backend user and a video user and a password which is secure. And I have my databases available for my user. So now we are in a different situation. We have the user created, we have the database created, which is a much better setup to run the application. So let's try that again. All right. So actually, the application is now seems to be working because I can run the backend program, and it doesn't give me any errors, which is a good thing. Just telling me that this is a development server. You shouldn't use it in a production deployment. So this is just for us to test, but we are fine. So I'm going to exit from this application by hitting Control and C. You may have to do it twice, and I'm back into my shell. So this was a good first step. We have created everything that we required to run the application, including the database stuff. Now we want to automate this so that this application, we don't have to run it manually. We can just run it as a service on our Linux system. So now I'm going to set up this service file. So I'm going to switch to my Ubuntu terminal where I have administrative rights. And I'm going to play with the systemd setup that is located in /etc/systemd/system, actually. If you look at this folder, you'll see that there are a bunch of files in there, and all these files actually relate to services that are running on your instance. For instance, here, SSHD, it's a service, and it's running on your system. And then you can interact with it using systemctl, SSHD. So here you have the log output of SSHD and information about what's happening on it. If you're in that view and you're stuck, you can press the Q letter, the Q key, and it will bring you back to your shell. So what we want is to set up a service that would run like this, but for our Python application. So in that folder, /etc/systemd/system, I'm going to create a new service file. I'm going to call it backend.service. You can call it pretty much whatever you want, as long as it's a service. This is what we call a unit file. It uses a syntax which is very similar to INI files on Windows, and it basically defines a couple of things about what your service is about. So I'm not an expert on systemd, but I'll try to write one like this. So this is what your unit file is about. So we are going to backend application 4640. This is a description of your service. We want this service to start at a specific moment in our boot process. We want to start it after the network has been available, because it's going to listen on the network. So we're going to use after a network the target. This is kind of specific to systemd, so you'll just have to get used to it. And something that's important here is that this unit file there should be a clear dependency on the fact that it requires MySQL to run. So we can set here in this unit file a dependency by saying that we want to make it depend on the MySQL service. And now I'm not sure whether it's MySQL or MySQL-D. So I'm just going to check that. There. It's MySQL.service. Where is it? MySQL.service. So that's our unit file. Now this unit file defines a service, and this service runs. Well, it's a simple service. It doesn't do anything really complex, and this service works with files that are located in /backend/src. So this is the main folder where we want to run our app. Then this service should be run by the backend user, and we want to start a specific command to make this service run. So here, this is where it's going to be a little bit tricky. Remember about your path and gunicorn. So you have files actually set up in this folder /backend/.local/bin, and you have gunicorn. And this is the WSGI application that we want to run in order to set up a production version of our API. So we want to run that binary because it's not in the backend user's path, and the backend user is using sh, which is a very primitive shell as its login shell. We are going to be safe and type in the whole path to gunicorn in the command that we want to run. So here I'm going to go /backend/.local/bin/gunicorn. Now, gunicorn has a very specific syntax. It uses the WSGI file as well, but you have to specify that you want to run the WSGI module in Python, the name of the Python object that contains your application. So this is just something you have to know. So I provide you with the command. You want to run WSGI:app, and then you are going to bind this server, because this is going to be a WSGI server, and we are going to bind it to a specific port. I'm not sure what I'm using in my instructions, but let's say for now I'm going to use port 5000. So I'm going to make this service bind, this is the -b, or bind to all interfaces on my instance. So everyone is going to be able to access, or it's going to be available to everyone on port 5000. Because we have a security group, no one from outside is going to access it on port 5000. So this is once again something that you may want to think about in terms of security, but it shouldn't pose major risks for us at that stage. It would be nice if this service would always restart when it breaks. This is sometimes not a very good idea. And then here we can add the fact that we want this to be started when we boot the instance in multi-user mode. So this should be your unit file. I did it based on my memory, so there could be things that are wrong. We'll see that very soon. I'm going to save that file. And now, in order to make systemd aware of the fact that there is a new file, a new service available, I'm going to call the daemon-reload command on my instance. Oh, I should use it with systemctl. Okay, and now I can have a look, and I can see that my backend service is disabled and it's inactive and dead. But at least I can check its status, so that's good. Now I'm going to enable my service, which is going to make sure that every time I boot the instance, the service is going to start. Since instances are supposed to be ephemeral, this is something that could be discussed in a larger discussion. But this is a good practice. And what's important to remember is that when you enable a service, it doesn't start it. It makes it enabled, but it doesn't start it. So now we are going to be wild, and we're going to start our service and see what happens. Well, nothing bad so far. And if we look at the status of our service, it says that this is our backend application for 4640. It's enabled. It's actually active and running, which is pretty awesome. And it seems to be working. It says listening at this address. So that's great. Now, what we need to do is to make sure that everything that comes, as I said earlier, everything that comes to /JSON on my front end is actually forwarded to my backend so that it can process it. So if you look at the backend source code, for instance, routes.py, you see all the routes that this backend application is serving. So you have /, which actually says that it should not serve the static HTML pages. And then you have the actual API endpoints /JSON and /add. So we might actually be able. Yeah. So the backend is actually responding. You can see it here. If you try to access the backend on port 5000, it says that you should not serve HTML pages through Flask. So this is not something that the backend should serve, but at least it's running. We can try to actually run it /JSON. And we actually get JSON back. We get a JSON message saying that the database is empty. This is something we'll fix later. But for the moment, we know that /JSON is working, the backend is working. This echo here is just cosmetic, because sometimes there is no line endings at the end of the output, so it's just easier to read. So you don't have to worry about that too much. Okay, the backend is working. Now we have to set up Nginx to make sure that, as I said, /JSON is being forwarded to the backend service. I'm going to edit the Nginx configuration file. And what's happening with Nginx is that you have the root folder here, and then you have rules. So this is the default rule. If you receive an HTTP request, then Nginx is just trying to find a file. So that's why you have try files here, a file that matches the URI that was requested. So if you try to access /JSON, it's going to look for a file called JSON, which is not what we want. What we want is when we hit /JSON, we want to forward or reverse proxy that HTTP request to the backend. So we're going to create a new location block in our Nginx configuration file. And we're going to say that this location block should match the /JSON URL. So all of these are URLs. They are not paths on your file system, right? And this /JSON is going to be actually forwarded to the backend. The backend runs on the same server, same instance as the front end and as Nginx. So here, if you proxy pass to localhost on port 5000, you will get to the API running with GUnicorn. So let's try that out. Restart Nginx. Now switch over to my browser. And I can now refresh the page here. And now I receive a different thing. I actually receive HTTP status 500 from the backend because the database is empty. So that's no big deal. It's just that we don't have anything in the database yet. So what we could do is just inject some data in the database just to make sure that everything works fine. Now I'm back in my shell terminal with, well, it's actually my backend user, but any user would work as long as you can run MySQL from it. So I'm going to run MySQL using the video user and a password, which is secure. And this is the user that my API is using. It uses the backend database. So I'm going to use backend. And then it's a very simple app. It's just using one table. This table only has two fields, the name and your BCAT ID. It's just an example app. So what you could do is you can insert into that table some values just to make sure that something happens on the front end. So, insert into item. You do that with name. I'm really bad at SQL syntax. Values. This is not my actual ID, but yes, that was expected. Maybe with the back quotes. No, okay, I'm going to double check the syntax. Apparently, I was not too far off. Something like this should work. I always use an ORM. Oh, 10 characters tops. All right. This happened because I typed in a very long number without thinking, and my column is supposed to be 10 characters maximum. So that was too long. If I used a different value, then it worked. Okay, so now I can refresh my page and change my screen sharing. Okay, and I refreshed the page already. Now you see that front-end is pulling information from the backend. If you access /JSON, now you see a list of JSON entries that are used by my JavaScript to update the DOM. So if I add new students, this, and refresh the page, now I get a new student. And then on my main page, I get a list of all the students. So this is how the application works. We've set it up from start to finish. Front-end setup, back-end setup, including dependencies, application setup, configuration, etc., configuration of Nginx, and then checking on the browser that everything works. So this is your objective, getting the application to work. Become familiar with it because we are going to use it throughout several classes. And as of next week, we will start making infrastructure automated to deploy that application, and slowly we'll move towards deploying it using Ansible.